So at the top level, we are talking about two software components. One is the cluster info right over here in the master node, and second one is the container info. Okay, so these are the two images which are going to be shipped from the DX UIM, and these are kind of the, I would say, reusable components from APM as well. So what is the significance of these two components? So basically cluster info is something that's going to reside on node like a master node, where it has the capability to collect the health metrics of the cluster, nodes, pods, and containers. And the significance of the container info is if at all there is a need to monitor in-depth metrics within the node, right? For example, today we get the health metrics like memory usage or CPU usage in KB, GB very quickly. But if at all we want to slightly get inside and understand what is the limit that was set and then what is the actual usage with respect to percentages, right? So those are the metrics, and few other deep metrics. Those we can get it from the container info. And the recommendation is get the cluster info image deployed on master node and get the container info deployed on each of the worker nodes along with the master node, so that we get the in-depth metrics like the per CPU percentage, memory percentage, which are more relevant for a person managing the containerization technologies in their organizations, right? Because if we create a trend chart simply saying that okay, so this much amount of GB is what is consumed from memory, so what is the actual limit and what is the percentage, right? So unless and until we get that percentage metrics, right, it really not going to give much of value add, and that's the significance of the container info. So the way the DX UIM collects the metrics after installing the or deploying these two images is, the cluster info exposes set of REST APIs, and DX UIM, hits those REST APIs through the REST-mount probe of DX UIM, pull the data into the database, and then bring it back with respect to processing, showing analytics, creating the trend charts, which I'm going to demo in a minute, right? So this is a very high level overview of a kickstart to get into the monitoring through DXUM for container orchestration technologies. With that, what I'll do is I'll quickly go with, how can we get these images deployed? How can we enable monitoring on DXUM? How can we create certain kinds of reports, service level agreements, and how can a knock screen that can be created for a persona like a person managing the overall cloud native technologies in a given organization, right? So can there be a single pane of glass irrespective of whether the containers are discovered from Kubernetes, OpenShift, Podman, Docker, or as Ravisha has mentioned, even from the cloud services, including Elastic Kubernetes or GKE, right? So let me start the actual demo now. So the starting point for deploying the two images that I mentioned for cluster info and container info is within the download section of the product. Okay, this is just for an FYI. So if we get into the 20.4 version of DX UIM, you will start seeing icon over here, right? So this actually lets us to create the secret key onto the cluster so that the two images can be downloaded. So the same instructions are available for our end users as well, customers as well, so that the images can be downloaded from the Artifactory within Broadcom, and then they can run, the two images can be deployed in the customer sites. So one second. If at all we have to start with the deployment of those two images, container info and cluster info, what is important is the YAML file, which is a typical, Kubernetes or OpenShift, deployment model. If at all we want to deploy certain images, there will be a corresponding deployment files. So for monitoring Kubernetes or OpenShift, there is a common cluster info.yaml file that has been created. So all this YAML file, the content contains is what is the cluster type that we are monitoring? Is it an OpenShift or a Kubernetes? We can give any of the cluster name which is relevant so that the cluster can be correlated on the monitoring end of DX UIM, and then the IP address is nothing but the master node IP. And the remaining content contains information about two images, as I mentioned. One is the cluster info 1.0, which we released, and second one is the container info. So after we deploy this deployment file, after we execute this deployment file on a master node, there will be images that will be created. All right. So this is a lab environment where we have set up a Kubernetes cluster. As you can see over here, there are 6 nodes in my environment. As you can see over here, there is one master node and 5 worker nodes. One of the worker node is not in a ready state. So now when I deploy that AML file, so within the DX UIM namespace, so there is one cluster info pod that is running, right? And then there are 5 container info pods that are running. The node where the container info did not get deployed is the one which is not in the not ready state. It's now with this setup, if at all we have to monitor from DX UIM, let's get into the operator console. Even before that, I just want to give a quick glimpse. If we do all of these things on DX UIM, what is the end result? Is something like this. So as you can see on this screen, there are containers discovered from different technologies. This tells a very high level overview about what is the total count of containers, active versus inactive, distribution by technologies. Service level agreements driven through PRD. This I'll come to that. Slightly interesting topic. Then few list views that are created with the list of nodes, whatever the nodes that we have seen, right? 5+1 on the Kubernetes cluster. So those 6 nodes are over here, and the 31 pods running on these 6 nodes, right? So this kind of a view, and again, we can further extend this for different technologies. This kind of a view will actually help, a user persona who is actually managing these cloud native technologies for a given enterprise, where they can keep it as a knock screen and then further drill down over here. So we can further extend this with some, alert color codes that, okay, if my nodes are in the red state, we can further drill down this into say kind of a Kubernetes list view. From here, we can specifically drill down to a particular node. This is a knock screen plus a capability that will allow to drill down further. So this is what we are going to achieve in this demo, and I'll quickly go through the steps now. All right. So let's assume that if I'm an existing user of a DXVM where the deployment is already in, and I did set up the cluster info and container info. So the starting point is select one of the existing robots or provision a new robot for monitoring the Kubernetes. So in my case, I have selected one of the robot, and then I'll get into the monitoring configuration, and then I'll set up a profile. So what this profile will actually do is, it helps in connecting to the cluster info, fetch the health metrics. As you can see over here, this is the master node IP. This all is good enough, okay, and then give the port what is there in the ML file, so that it creates or compiles certain API endpoints, connects to the cluster info, captures the health metrics across cluster nodes, pods, containers, and many other services. And then the data will be discovered and then getting into the UIM database. So this is a setup profile just for a connection, and these are the various child profiles, right? I'll not get into each of this, but what these child profiles will actually contain is set of quas. what we would like to actually monitor, right? At a cluster level, maybe I'm interested in what is the state of my cluster, what is the aggregate CPU usage within the cluster for all the nodes that are running in the cluster, right? Or what is the aggregate memory usage? What should be the desired number of pods and what are the actual running pods? So these metrics would help us, to triage how the cluster is performing. And as I said, there are a bunch of metrics over here, but categorized and segregated at various services and entities within the Kubernetes cluster. And a similar kind of a structure that you'll also see for OpenShift monitoring. From a landscape or coverage perspective, we do support cluster level metrics, node level, pod level, services, and container level metrics, control plane. So these are the typical entities that any Kubernetes administrator would like to see. So it's all about enabling the required costs and then alarm policies that will be created. The monitoring will be kickstarted. It shouldn't take more than 5 to 10 minutes to quickly enable the monitoring configuration once the cluster info image is up and running on the cluster.